discuss about the example problem for a simple Rankine cycle or the ideal cycle. Okay. So, termo po ngayon. So, we have the ideal Rankine cycle. Okay. So, first, do you have your state table with you? Raise your hands if you do. Okay. And so we proceed. So a steam power plant operates on the ideal Rankine cycle. So the steam enters the turbine at 7 megapascal and 550 degrees Celsius. It discharges and to the condenser at 20 kilopascal. So we need to determine the cycle efficiency. Okay. Anong una yung gagawin, class? Solution. You draw your draw the schematic diagram of the simple or the ideal Rankine cycle. Dapat alam niyo na to. Here the boiler, the turbine, so close the condenser, after that the pump. Yan. From point 1, 2, 3, 4. Sa turbina, we have to work. This generate electricity. We have also the condenser at point 2 to point 3. So, meron tayo dito, heat is rejected. Ay, mali yung arrow. Ito na, no? So, heat is rejected. While here, we have the work of the pump and heat added at the boiler. So, this is the first. This is the schematic. Also, if we have the schematic, you will draw the TS diagram. Masyado bang mabilis si ma'am? Kasi 9:30 lang. Hanggang 9:30 lang. So, we have TS. Ano yung given sa atin, class? We have the pressure at point 1. This is the pressure line. This is also the pressure at point 2. Ayan. Since given sa problem, this is your TS. That is a, ano yung given sa atin? 550. Okay, so pantayan class yung 550 nyo. We have, but before that, drawing the TS diagram, we need to consider what is the given in the problem, that is 7 MPa and 550 degrees Celsius. Ang given sa atin, mamaya i-continue natin. Temperature at 1 is 550. Okay, what is the T saturated of 7 MPa? Anong page yan? Page 12. T sat is 285.88. Therefore, yung temperature 1 natin is greater than the C at saturated. Therefore, fall siya sa superheated vapor. Okay. So, saan ka pupunta? Punta ka sa table 3. Anong page? You have your 7 MPa. Yan na. Okay. So, this is page 69. Okay. So, page 69. Page 69. So, ano yung kukunin natin? Importanteng property. Okay, so finding all the cycle enthalpy and the other important properties values when it comes to thermal efficiency. Okay. Page 69. Ano yung property na kukunin natin na importante? What do you think? So, H1, what is H1? .9. Ano pa? From process 1 to 2. In a Rankine cycle, ano class? 550. We have 350.9. And we have also the enthalpy at point 1. 6.9486 per kilogram Kelvin. So, bakit yan lang yung kinuha? Kasi mahaba-haba to class. Since superheated na si point 1 natin, ayan, pakita ko na. Most likely, ganito yung lalabas natin na. Okay. Pangit ng drawing ko. Ayan. So, 550. So this is now your 0.1. But we all know that in 0.1 to 0.2, that is isentropic expansion. So, pababayan class. Okay. Check natin kung mag-follow sa wattage. Okay. So, from process, red pala, masulat ko. It falls under isentropic expansion. Ano class yung given temperature natin? Pressure 1 and the steam turbine enters at 7 megapascal and it is to condenser at 20 kilopascal. So we have the pressure 2 at 20 kilopascal. O, sa steam table nyo, makikita nyo is MPa. Convert it into MPa. What is now your pressure? Pressure at 0.2. Sige nga, walang nag-chat. What is the pressure at 0.2? If we have 20 kilopascal. What is the pressure? Anyone? Okay, so we have now 0.02 MPa. So this is now your properties. Pressure 1 and pressure 2. Yes, class, because pressure 1 is just equal to pressure at 0.4 and pressure 2 is equal to pressure at 0.3. So this is the constant pressure. Yan. Constant yung pressure. So we have now 0.02 MPa. Anong table? Punta ka ulit sa table. Table what? Table 2. Okay. Table 2, 0.02. Page 8. Tama ba? Page 8. Ayan. Tama, class. Page 8. So, we proceed. We have now the pressure at 0.2. Ano yung gagawin natin? We all know isentropic expansion. Using this value. We'll find now the, take note yung SG natin dito is ilan? Entropy at saturated vapor 7.985. Okay, so mas mataas si SG natin kaysa sa S2. And considering na yung SF natin, saturated entropy at saturated liquid is 0.832. So, mas malaki naman yung S2 natin sa SF. So, automatically, wet region. Okay? So, therefore, hanapin natin yung quality at 0.2 using this formula. Kasi alam na natin yung specific entropy at given 0.2. SFG2. So finding the quality at 0.2, we have the S2 minus SF2 over the SFG2. Finding for the quality using the property of 0.02 MPa at table 2, your S2 now, your quality is what? 86 kilojoule per kilogram Kelvin. SF is 0.8320 all over yung SFG mo, ilan? 7.066 kilojoule per kilogram Kelvin. So we have now the quality at 0.2. Okay. What is now the quality at 0.2? Anyone? The quality at 0.2. Sa condenser pa lang tayo entering. This is from 0.1 to 0.2 is, this is the turbine. Ayan. Ayan. So we have now 0.8643. Quality natin is 86.43%. Okay. Ano yung hahanapin natin at 0.2? Reduce of the enthalpy at 0.2. Yung importante lang hinahanap ni Mama to determine the cycle efficiency. So we have now enthalpy at 0.2. At same table table 2, page 8. We have HF2, 251.40. Sa quality, ano yung HFG natin? 2358.3. So this is now your enthalpy at 0.2. Compute for the property. So we are just solving the properties from turbine, leaving the turbine. Kasi 0.2 tayo. 0.2 to 0.3. What is now your answer in enthalpy? Enthalpy at 0.2. Wala. This is 86. What is now your answer, class? 2289. We have now 2289.68 kilojoule per kilogram. Okay. Considering that, we have now the enthalpy at 0.2. Balik tayo dun sa TS diagram natin. From turbine, so dito yung class the schematic and the TS. 2 to 3 is condenser. We all know that all the properties at state 3 is a saturated liquid. Okay? So, yan po lagi yung assumption at state 3. Are you leaving the condenser? Entering the pump. So, saturated liquid po yung palaging assumption natin. Saturated liquid. Since we all know that from pressure 2 to pressure 3 is a constant pressure process, yun po yung magiging basehan natin. Yung pressure 2 natin is 0.02. MPa. So our pressure 3 is also equal to that. Using the same table, okay, using the same table, we proceed now to the saturated liquid values. Ano yung kailangan natin at saturated number 3? Yung specific lang is yung saturated liquid natin. Saturated liquid at specific volume at a saturated liquid at a given pressure. So we have now the specific volume at 0.3, which is equal now to the specific volume at 0.3. So that is now equal to 1.0172 times 10 to the negative 3 per kilogram. And we also have the HF at 0.2. Yan, para hindi kayo. That is now your H3, which is equal to 251.40. 40, tama. 21.40. Tama yung H3 ko. HF2. Kilojoule per kilogram. HF 1.01. Ayan. 251.4. Okay. Okay. So we have now the properties at 0.3. So we now proceed in solving the state 4 class. In state 4, we don't actually use step table but prefer to use the energy or the approximate work of the pump. Okay. So, pag sa state 4 class, kadalasan ginagawa para makuha yung values natin is, para makuha natin si H4 natin, we make use of the work of the pump. We have the specific volume at 0.3, pressure 4 minus pressure 3. Alam naman natin that the pressure 4 is just equal to pressure 1 and pressure 3 is equal to pressure 2. Yung pressure at 0.1 natin, given sa problem that is 7 megapascal and this is 0.02 MPa. We need to compute first for the work of the pump. Specific volume. Yan, substitute mo lang. Ano yung pressure mo at 0.4? That is 7 MPa minus 0.02 MPa. What is now the work of the pump in kilojoule per kilogram? Sige nga. What is now the work of the pump given sa atin yung different pressure? So, pinaghalo-halo na yung different properties. Dapat alam niyo kung ano yung nangyayari dyan. 4 to 3. So, may pump tayo dito. And 4 to 1 is the boiler. Diyan nangyayari yung boiler na. So, what is now the work of the pump? Wala. Work of the pump. Huwag kakalimutan yung times 10 to the negative 3. Okay, yan. May answer na si Adeline mo. We make use 7.100. Ilan yung 0? Tatlo. Dalawa. Zero. Ilan yung nakuha nyo? Bakit mali? Tama yun. 1.0. Tatlong 0. Ayun. Yeah. So, gagamitin natin is the work of the pump at 7.1. Ayan. Kilojoule per kilogram. Kasi 5.6 to. 0.056. Yan. 0.0. Oo, pwede. 1, 2. Ayan. Ayan. Tama. 0.0. Ayan. Bakit ayaw? Okay, balik tayo. Okay. So, we have now the work of the pump. But we all know that pag hindi nyo class alam, i-draw nyo ulit. Balikan nyo tong schematic. Yan, schematic diagram sa may pump. Pag hindi nyo na alam yung gagawin nyo, energy equation ka ulit. Pasok dito yung 3, lalabas yung 4, at saka may work of the pump. Diba? So, all entering H3 plus work of the pump. So, in finding for the H4, we make use of this plus the work of the pump. Yan. Sige nga. Ano nga yung H3 natin? We have now the H3. Ano kasi yung H3 natin? Excuse me. In computing for the H3. Ayan, dito na. 251. Ayan, thank you. So, H4, we have 251.4 kilojoule plus work of the pump. And 4 decimal lang naman. So, what is now the H4 into decimal? The enthalpy at 0.4. What is now the process? Ayan. 200. Ilan class? 250. Yan. 258.5. 258.5. Tama. 58.5. 41. Ano yun?
Ma'am, question lang po, ma'am.
Opo.
Yung sa work po, ma'am, yung 7.2,
Opo.
wala po siyang ano po, ma'am, yung times 10 raised to negative 3, tatanggalin po yun.
Okay. Sige. Good question. Okay, take note that here we have lagyan natin ng red. This is times 10 to the negative 3 and this is in MPa. Okay, in putting in your calculator, para hindi kayo maguluhan, ilagay nyo dyan 0.001 Ayan, isulat mo yan sa calculator mo para eksakto ka. This is now in cubic meter per kilogram. And yung 7 Pascal mo, i-kilopascal mo. Kilopascal minus 1 to 20 kilopascal. Yan. I-compute mo yan. Ano matitira dito? Sige nga. Calculator, in your calculator. Kasi ang matitira dyan sa'yo dapat is yung kilopascal natin is kilonewton per meter squared. So, kakancel yan. Ayan. Cancel to. Matitira isa. To. Matitira sa'yo is kilonewton meter per kilogram. Your Newton meter is in joule, so kilojoule per kilogram. So what is now the answer here? Ayan. In 0 point. Parehas lang ba? Sige nga. What did you find? Okay. So that is same. Para mas maintindihan ng classmate nyo. So ganun po. 7.100056 kilojoule per kilogram. This is now your work of the pump. Yeah. So, same lang sila. Yan. Pinakita ko lang dito yung times 10 to the negative 3 mo. Mga ganito. And your MPa into kilopascal. Nasagot na po ba? Okay. Balik tayo sa work of the pump. Okay. O, ano yung answer nyo dito? 251.4 plus 7.1. Okay. Ano yung sagot? 250. Ayan, malayo. Kilojoule per kilogram. Tama ba yung H4 nyo? We have now the enthalpy at 0.4. So, wala pa tayong sinusolve, cycle efficiency. So, this is now your, para makita nyo, pang color. Yung color gusto nyo. Ito. This is now your, from 0.1 to 0.4, that is your 7 MPa. This is 0.02 MPa or your 20 kilopascal. This is 7.0 MPa. Yan. Naintindihan po ba to? 258.5. Okay na ba? Can we proceed now from that point from that reference? Okay. Naintindihan na ba ba, class? H1 to H4. Ayan, nakuha na natin si H1 hanggang kay H4. Ano yung gagawin na natin? We'll compute now for the work ng turbina natin. Ayan. Entering. So, we have now the turbine. Pag hindi nyo na class, i-draw nyo na lang. Ayan. Entering, leaving. How do you get the work of the turbine? H1. Work now of the turbine is H1 minus H2. From your energy equation, what is the H1? Balikan natin. 35.35. Yan. What is the H2? 2 to 89. Check na natin. 0.68. So we have now the work of the turbine. What is now the work of the turbine? One, two. Yung iba, 35.30.9 minus 2 to 89. 8. Okay. We have now 1, 2 for 1.22 kilojoule per kilogram. Ayan. Di pa tayo pinapahanap sa atin is the cycle efficiency. We all know that we have now, excuse me, yung work ng pump natin, nakuha na natin, class. Okay. Yung work ng pump natin, nakuha na natin. So, take note, yung work ng pump natin, pump, negative work po yung nagagawa niya, class. Negative work. Okay. So, if we, kung babalik na rin lang naman to, class, we have the work of the pump. Negative work. So, dito na yan sa work net. Okay, in solving for the work net, or the net work, yan, we have the work of the turbine. Addition siya, class, ng all ng work. But take note, yung pump natin has a negative work, so ito na yung pinapagamit ko sa inyo para hindi kayo malito. Work of the turbine minus work of the pump. So, finding for the work net, we have now the work of the turbine minus work of the pump. 7 point. Yan. Gamitin lang natin yung 4 decimal. Okay, we have now the work net. Ano na po yung work net natin? Ayan. Yung net work. What is now your answer, class? 1234, 1241, 7.1. We have now 1234.12 kilojoules per kilogram. Okay. After that, we need to find the heat added at the boiler. So, if this is your boiler, labas dyan is yung H1, entering is yung H4. Heat added, the heat added or the in, okay, the heat in the system. Okay, so heat addition, yan, pag hindi mo alam yung formula, hindi energy equation ka, H1 minus H4. Okay, finding for that, we have now the QA, H1 Ito, 3530.9 kilojoule minus H4, 258.5 kilojoule per kilogram. So we have now the heat addition. What is now the answer? 30.9 minus 258.5. Yan. We have 3,272.4 kilojoule per kilogram. Yan, nakuha na natin. So, in finding for the thermal, anong pinapanap sa atin? The cycle efficiency. Okay. In finding for the cycle efficiency, yan. You can always have the work net over the heat added. So, what is now the work net? 34.12 kilojoule per kilogram divided by the heat added. Okay. Okay, so input divided by the output. Okay, that is the efficiency. What is now the efficiency? Yeah. Approximately 1 hour magsusolve para sa isang cycle efficiency. Okay, what is now the cycle efficiency? We have now, what is now? 12 divided by 3272.4. Yes, we have 37. Ano yung answer ng iba? We have now 37. Ayan. 37.70. Ano sa inyo? Ayan. 51%. So this is now your final answer in solving a ideal Rankine cycle. Okay? Intindihan? So, ganyan yung kukunin mo. Hindi mo naman kukunin lahat ng properties niya. Ang importante is the enthalpy, the constant entropy process. Okay? So, yan po. That is the ideal Rankine cycle. That is the ideal. Okay? The ideal Rankine cycle. Okay. How about, nakuha na ba yung sa Rankine? If we have the ideal Rankine cycle, we proceed to the actual Rankine cycle. Okay. Using the same problem, okay? Ibigay ko sa inyo. Same yung problem natin, ha? Para mas maintindihan si actual Rankine cycle. Okay, mahaba-haba to. 100 megawatt steam power plant. Ma'am, paano yan parehas si Eva? Okay. The rates on the Rankine cycle, but with the turbine and pump efficiencies of 85%.
Ginamit ang battery. Kaya pala ayaw i-charge. Ano? Kaya pala ayaw mo i-charge. Walang battery siya. Ginamit mo. Ay! Oo. Diri! Kaya ayaw i-charge. Sa base ni Kuya. Oo! Kahit tinisting yan to. Sana.
Okay, so this is now the actual Rankine cycle. So we have a 100 megawatt steam power plant operates on the Rankine cycle, but with a turbine and pump efficiencies of 85%. The steam enters the turbine at 7 megapascal and 550 degrees Celsius. It discharges to the condenser at 20. So same yung given ha. Ibig sabihin hindi na tayo hanap ng properties. Yan. 550, 20. Pero may iba na given. Okay? So, anong hahanapin? So, determine now the cycle thermal efficiency. Ayan. We have here the steam flow rate. Ayan. The cooling water flow rate in the condenser. Ayan. If given sa atin yung cooling water properties, ayan, enters at 20 degree and leaves at 35 degrees Celsius. Okay. Yan same lang sa atin, but ano yung mga additional given sa atin? We have the turbine pump efficiency is 85%. Sinabi parehas na 85% and pinapahanap sa atin cycle thermal, the steam flow rate, and the cooling water rate. Given sa atin yung entering water and the leaving water. Okay? Leaving temperature of the water. Okay? To represent this, ayan, black. Ulitin ko lang yung schematic diagram natin. We have the boiler. We have the turbine. Ayan. All throughout this year's class, parang masasaulo nyo na to. Ayan. More work sa turbine, shaft work. And meron tayo electricity dito generated. Point 1 to point 2, we have now the liit ng condenser. Ayan. Condenser. After that, we have the pump. Practice more class para matrain kayo. Okay? So, this is the turbine. Turbine natin. Condenser. This is the cooling water. The pump. Yan. Ano meron sa boiler? We have the heat addition, work turbine, heat rejection, hit QR, my work of the pump. Ayan. So, take note, ano yung bagong given sa atin? We have now the efficiency of the turbine at 85%, the efficiency of the pump at 85%. Ano yung magbabago nating properties from point 1, 2, 3, to 4. So, magkakaroon na tayo ng 2 prime here. That is now your actual dahil sa pump efficiency, turbine efficiency. After that, magkakaroon din tayong 4 prime dahil sa pump efficiency. Okay. Intindihan? After this, you draw now the TS diagram. Yan. TS diagram mo. Gutom yung TS. Wait. We have now your TS diagram. Wala ang pinagbago. Okay. Anong mangyayari? Kanina ganito yung graph natin. From point 1 to point 2. Ayan. Dito. Okay, we have point 1, point 2, 3, and 4. Ito yung kanina. Since given na sa atin yung efficiency niya, so hindi natin alam kung saan magpo-fall siya, kung nasa wet region pa ba. Ito yung magiging dalawang option mo. Pwedeng dito pa rin siya sa loob or dito sa labas. Okay? Yan. And this one. The 4 prime. Yan. Sa labas talaga siya. Okay? So, we proceed now. Given sa atin yung 7 MPa and the 20 kilopascal. Okay. Ano yung una mong gagawin? We have this. We have also the entering temperature of water. Nakalimutan ko. And the living condition. Tama ba? 35. Yan. Yan. So, this is the actual Rankine cycle. Ano yung una mong gagawin? Okay. We need to determine now the actual enthalpies of the cycle. Okay, so alam naman natin na given na sa atin yung pump efficiency. Okay, pump efficiency 59. Okay, using that, this is class the formula in the turbine efficiency. Okay, so sa turbine efficiency, that is the actual work of the turbine over the idea of work. The turbine compared to the pump efficiency that is now the ideal work of the pump all over the actual work. Yan. So, minsan kasi ginagawan ko to ng acronym. This is TI and this is PIA. Okay? turbine efficiency, actual over the ideal, and the pump of the work, ideal over the actual. Okay? Paano po yun, ma'am? Punta na tayo doon. In solving the problem, given sa atin yung pump efficiency, turbine, 85%. Okay. Hahanapin natin si H2 prime using the turbine efficiency. Okay. And yung H4 prime natin using the pump efficiency. Ano yung gagawin mo? We all know that the pump of the turbine, punta muna tayo sa turbine. Turbine. Okay. Di ba alam natin that the work of the turbine, yung ideal, we have H1 minus H2. Sa pump natin, we have H4 minus H3. Pero hindi naman talaga to yung ginagamit natin. Pag nakukuha tayo ng work of the pump, we make use of this one. Okay. But since we have now the actual, in the actual Rankine cycle, maulan class. Okay. Ito muna yung gagamitin natin when given sa atin yung efficiencies. Okay. So, turbine tayo, focus. So, turbine work is equal to the actual. What is the actual class? So, H1 minus H2 prime over the ideal H1 minus the H2. While here in the pump work, ideal over the actual. Ano yung ideal natin? H4 minus H3 over the H4 prime minus H2. Okay. Computing for H2 prime, we have, ano yung gagawin ko nga? Shift solve nyo na lang class, 85%. Ano yung H1 natin? Balik ulit tayo dun sa problem number 1. Ay, sinulat ko na yun. 35. Ayan. Ito na. May work of the turbine tayo. Gamitin na natin to. 1241.22. 1241.22. Baka tanongin niyo ako kung saan ko yung kinuha. H1 natin, 3530.9. H2 prime. What is now your H2 prime? This is equivalent to work of the turbine. Class. Your H2 prime. Si mom, di nga sa mo turo. Ayan. 3530.9 minus alpha. Alpha x. What is now your x? Nakuha ko na. What is your answer, class? Okay. 2,475.86 kilojoule per kilogram. We have now here, okay, ano yung sunod natin kukunin? Yan, we have now the H2 prime. The H4 prime. We have now the pump efficiency. That is equal to H4 minus H3. H4 prime minus H3. 85 then, as stated in the problem, H4 minus H3. This is equal to, saan na? Work of the pump, 7.1. H4 prime. Ano yung H3 natin? Baka malito na kayo 251.4. We have now the H4 prime. What is the H4 prime? Equal to 51.40. What is now your answer? In H4 prime. Ano yung answer, class? 2. Okay, 259.75 kilojoule per kilogram. We have now the prime. Ma'am, bakit kinuha natin yan? Class, yes, because it will affect now the work net of the different processes. So, mag-iiba class yung cycle efficiency natin, ha? So, we will now compute for the actual work, which is equal to H1 minus H2 prime. Yan. Okay. Ano yung H1 natin, class? 35, 30.9. What is now the H2 prime? What is now the actual work? Sige nga. Actual work. Work of the turbine. What is now the actual work of the turbine? Can we have it? Anyone? Actual work of the turbine, ma'am, bakit kailangan natin? Isa lang nag-compute? Okay. The other people. Nasaan na yung iba? Okay. Three, 1,000 ano? 1,000 ano yung iba? We have now 35, 30.9. We have now 1,055.04. Tama ba yung sagot nyo? Okay. Kilojoule per kilogram. We will also compute for the actual pump work. We have the H4 prime minus H3. So 59.75. minus yung H3 natin. Ito yung H3 natin. 251.4. Sige, paki-compute niya for the pump work. What is now the pump work? We have 8.35 kilojoule per kilogram. Okay. So in computing for the cycle efficiency, we always compute for the work net and the boiler over the heat added in the boiler. Okay. So we have H1 we have now the heat added. Okay, so boiler class. Yung boiler natin entering is 4 prime now and 1. Heat added. H1 actual. H1 minus H4. So the heat added now, H1 natin is 35.9. H4 prime natin is 259. What is now the boiler the actual heat added in the boiler? 3530.9. What is your answer? Ano class? May mali ba? 35, 30. 35, 30 baga class? Ano yun class? May mali ba? Oh, wait. Okay. 37 ba? Bakit 37? Ano yun class? May makita akong iba. Okay. We have now through to 71.15 kilojoule per kilogram. Okay. Finding for the in an actual Rankine cycle, we compute now for the actual thermal efficiency. So go to the work net over the heat added, work of the turbine minus work of the pump, actual heat added. Finding for the actual, we compute now turbine 1055.04 kilojoule per kilogram. Work ng pump 8.35 kilojoule per kilogram divided by the heat added. So we have now the actual thermal efficiency. Ilan? Given yung mga different pump efficiencies, we can now compute for the cycle efficiency. Or this is just equal to have now the cycle efficiency at 32%. Okay, may 1 point na tayo. The next question now, given sa atin yung steam flow rate. Given sa atin class is the 100 megawatt steam. Okay? And finding for the flow rate of the steam. Okay, paano yun? Given sa atin sa problem the 100 megawatt, so that is the total net power. Yan. Yan yung na-produce. Okay. Finding for that mass of the steam, NP. Kadalasan. CMS na lang. Excuse me. Mass of steam. Pag-given na sa atin to class, ito na. Over that is divided by the network. Per unit mass. Ito yung actual kasi given naman sa problem. So we have 1,000 megawatt. So in kilojoules, that is like this, kilojoule per second. Joule per second is in watt. Over the actual, this is the work net. Ito ay hindi ko pala ito na. Okay, hanapin nyo kasi yung work net natin. What is the work net? So, tingnan, may nag-chat na. Kilojoule per second over. Tingnan yung work net natin. 55. 1046.69. Okay. So, we have the mass of the flow rate or yung steam natin, flow rate of the steam divided by the 1069. We have 95 point, ano yung answer niya? 54 kilogram per second. Kilojoule per second, the reciprocal, kilojoule. Cancel, kilogram per second. So we have now, pangalawa, we have now the mass of steam. Okay. Going back, na yung pangatlong tanong sa atin, determine the cycle, the flow rate. Ayan, cooling water rate, condenser cooling water enters at 20 and leaves at 35. Okay. So, first law, analysis, na condenser. So, ito yung condenser natin. Yan. Entering 20, leaving 35. Okay, H2, H3 may heat, rejected. We all know that heat rejected is just equal to the MCP, the mass of the water. Okay? Ay, may actual pala to class. Nakalimutan ko yung actual. Okay? we proceed yung heat rejected natin since given na yung mass of the steam equal siya sa H3 prime minus the H4. Bakit H4? Bakit H3? Mali. Okay. Tama ba? H2, 2 and 3 sa condenser. 2 prime 3. 2 prime. Baliktad pala si ma'am. Yan, double check nyo class. Para hindi kayo malito, we have the H2 prime, H3. Okay. So, now the mass of steam. Nilagyan ko lang to kasi magiging kilojoule na yan. Ngayon, we have the H2 prime minus the H3. Okay. So, sa heat rejected class, equal naman na siya ng energy sa mass of the, kasi pinapanap sa atin is the mass of the water leaving. Mass of the cooling water. And equal siya sa H ng leaving na water minus entering na water. Paano natin yun makukuha? Because given sa atin yung, ano yung entering natin, class? Saturated liquid. Saturated liquid at entering temperature which is equal to 20 degree. Punta ka sa 20 degrees Celsius. Kasi water naman siya, you can use the steam table. Kasi steam baga class galing sa tubig. Table 1. Page 2. We have now HF at 20 degree. Kasi saturated liquid naman talaga siya. We have 83.96 kilojoule per kilogram. And also the saturated liquid at leaving temperature, which is equal to 35. So 35 degree. Same page. Table 1, page 2. We have HF at 35. That is 146.68 kilogram. Okay. So by energy equation, entering is just equal to leaving. So the heat rejected, kasi kung ano yung pumasok class, yun din magiging energy na lumalabas na tubig. So we have the mass of steam now. We have H2 prime minus H3 equal siya sa mass MC, that is the mass of the cooling water. Yeah. H na out minus the in. Okay. So the mass of steam, pinapanap sa atin is the mass of the cooling water. Yeah. What is the mass of steam? 95.54. H2 prime. Binaw ko ng class. H2 prime. Haba. Masaan na? Ayan. 2475.86 minus what is H3? H3. Yan. Sana yan, H3. Pag mali ka dito pa sa isa, mali ka na sa lahat. H3, 251.4. Kaya class, pag nagsusulat ng solution sa termo, di namin inaalaw na magsulat sa likod ng papel. Lahat paunahan. Sa unahan lang. Okay? H out. Ano yung out natin? 146. In is 83.96. We have now the mass of the cooling water. Yan. Bus na. 930. Okay. What is the mass of the cooling water? Yan. Bilisan ko kasi may next subject para makapahinga. 75.86 minus 251.4 divided by 146.68 83.96. Yeah. We have now the mass of the cooling water. Oh, paano yun, ma'am? Ganito para mas maintindihan. The answer now is 3388.47. Ano yung magiging unit mo? Okay. Ito class, sa taas. Yung sa taas, steam. That is kilogram steam per second times kilojoule per kilogram of steam. Diba? Yung sa taas. Sa baba naman class, times H. Sa baba, we have kilojoule per kilogram of, hindi na siya steam, water. Okay. Kakancel yung kilogram of steam mo. Cancel yung kilojoule. So, matitira na is yung kilogram of water per second. So, yung unit natin dito is kilogram of water per seconds. That is just in kilograms. Okay? Okay? Naintindihan ba? So, this is the actual Rankine cycle. Okay. Pag mali ka sa pinakaunahan, mali ka sa pinakahulihan. Double check. Wala pa tong double interpolation. Okay, class. So, that is the example problem of an actual Rankine cycle. Yan, mas mahirap kung wala kasing problem na sinusolve sa actual Rankine cycle. Okay? So, if you have any problem, concern, anything, just PM ma'am. I-chat nyo na lang si ma'am. Okay, ay ito. So, paano natin mako-consider if sa labas or sa loob yung actual efficiency natin? I mean, yung 2' natin. Sige nga. Ano nakuha natin? Yung H2' natin is 2475. Okay. From the steam table, ano yung una nating value sa H2? H2. Ano yung quality niya? H2. Ay, wala pala. Hindi pala pinakita dito. At ano lang. Dito na lang. So, punta ka doon sa same pressure at point 2, 0.02 MPa. Tingnan mo yung Hg doon. Na, yun na page. Page. Saturate 0.02. Page 8. Yung Hg natin is Hg is 2609.7 kilojoule per. Ibig sabihin, class, nasa loob pa rin yung H2 natin. H2 prime. Ibig sabihin, here class, so dito pa rin siya. Yung 2 prime natin, from the problem, magiging, ito. So, dito. Yan. Sa loob pa rin. Katabi ng, this is now your 2 prime. Okay? Paano kung pinapahanap ko sa what is now the quality at this point? Ayan. Paano mo naman solve yung x2 prime natin? Okay? So, balikan mo lang. H2 prime now is equal to HF2 plus the quality at point 2, HFG2. Finding for the quality at that point using the H2 prime. Yan. Same table Page 8, table 2. Yan. Wala to sa problem pero pinapakita ko na sa inyo. H2 prime. Ano yung H2 natin? 2475.86. HF2 251.4 divided by HF 2358.3. Yan. Wala sa problem, pero pag pinahanap ko, this is now your quality at that point 2. What is now your answer? 275.86 minus 251. Excuse me. 2358.3. O, diba? So, it falls again into the mixture. Ano, class? Ano po ang answer nyo at this state? What is your answer? What is the quality? Okay. We have 94.32%. So, that is now your quality at point 2. At the actual Rankine cycle. Okay? So, yan. Mas mataas siya. Diba? Ano yung una natin na quality? Dito. Nakuha natin is 86. So, from 86, dito yung 2 prime natin, 86.43 naging 94.32%. So, that is now your actual quality at point 2. Okay? Yan. So, what is the sikreto in solving this? Okay. Pag mali ka sa pinakataas, magiging mali lahat ng sagot mo. Lalo kung mali yung conversion mo. Okay? Into kilopascal to megapascal. Okay? So if you have more question, then PM ma'am. PM na lang si ma'am. Okay? Para maka-ready na kayo sa next subject niya. Okay? So that is now the actual Rankine cycle.